The age of Saturn's rings has puzzled scientists for decades. There's evidence that the rings are young, only hundreds of millions of years old, but other evidence that they're ancient, perhaps as old as the planet itself, billions of years old. How can we reconcile these two seemingly contradictory pieces of evidence? To answer this question, we need to learn more about how Saturn's rings formed. There are two main theories for how these rings formed. One is that they came from a shattered moon. This would mean that Saturn's rings are relatively young because moons tend to form early in a planet's history, and then it is kind of like a second event that created the rings when the moon got destroyed. The other theory says that Saturn's rings formed at the same time as the planet over billions of years. So which one of these ideas is correct? In this video, we're going to look at evidence for both models and see how they fit the data. Let's start with the model that says that Saturn's rings are young. In 2004, the Cassini spacecraft discovered that some of Saturn's rings were only a few hundred miles wide. That was surprising because if the rings had been around for billions of years, you'd expect them to have spread out over much larger distances by now due to gravitational perturbations. It seemed to indicate that the rings were too narrow and therefore too young to have formed at the same time as Saturn. But there's another piece of evidence that the rings are young, and it comes from looking at the rings themselves. You see, the majority of Saturn's rings are opaque, but there are parts of the rings where we can see through to the planet behind. This happens when the rings are only 1 or 2 miles wide. And in these cases, the ring particles are so spread out that light can pass between them. But in the opaque parts of the rings, the particles are much closer together. If Saturn's rings are young, this makes sense because over time gravitational interactions would cause the particles to bump into each other and spiral inwards towards the planet, making the rings narrower and eventually causing them to rain down onto Saturn. On the other hand, if the rings are ancient, you'd expect the particles to be spread out over much larger distances because they've had billions of years to do so. So the fact that the rings are narrow supports the idea that they are relatively young. How young? Well, in 2006, scientists used computer simulations to estimate that Saturn's rings couldn't be much older than 100 million years. In 2018, new analysis of the same data gave an even tighter constraint, saying the rings had to be less than 200 million years old. Now, where did this age range come from? Where did these numbers come from? Well, remember that the particles in Saturn's rings don't just sit there, they actually orbit around the planet. They orbit at different speeds depending on how far away they are from the planet. Particles close to the planet move faster because they're affected more by Saturn's gravity, and particles further out move slower. This means that over time, particles will cross paths and collide. And these collisions change the orbits of the particles, shifting them inward or outward. By measuring how many particles are in certain parts of the rings, we can work out what the particle orbits are and thus how fast they're moving. If the particles are moving fast, then they must be close to the planet and therefore the rings are young. If the particles are moving slow, then they must be further away from the planet and therefore the rings are old. Scientists can use computer simulations to model the evolution of these orbits over time and compare it to observations. They want to find the oldest possible age for Saturn's rings. So they assume the particles are moving as slowly as they possibly could and still be in the rings today. If they were moving any slower, they'd have fallen out and rained down onto Saturn long ago. They found that if Saturn's rings were no older than 200 million years, that would require a special initial condition. For the orbits, basically you'd have to start off with a population of particles that were already moving really slow. Otherwise, over time, the particles would start moving faster and eventually they would have moved so far out that they wouldn't be in the rings anymore. This would imply that Saturn's rings are young. But wait a second, I thought these computer simulations showed that if the rings are young, then they should be spread out over much larger distances. But that's not what they show. No, that's right. The computer simulations do show that if the rings are young, then they should be spread out over much larger distances. So how can we reconcile these two pieces of evidence? Well, the key is that there are two different types of Saturn's rings. The outer rings are opaque and a few hundred miles wide, whereas the inner rings are transparent and only 1 or 2 miles wide. And the computer simulations have shown that the outer rings can be ancient, billions of years old, whereas the inner rings are young, only a few 100 million years old. That's why the two models give such different answers. The two types of rings formed in different ways. The outer rings formed gradually over billions of years from the material in Saturn's atmosphere, whereas the inner rings formed relatively recently when a large body, possibly a moon, crashed into the outer rings. It's like if your mom made you a grilled cheese sandwich over billions of years, adding 1 slice of cheese every year. That would be the outer rings. But then one day she slammed the bread on the table and added a bunch of cheese all at once. That would be the inner rings. Now, what caused this sudden burst of ring formation? Scientists aren't sure, but they have some ideas. One is that the moon that formed Saturn's rings got knocked out of its orbit and crashed into the planet by a large object that passed by the planet. Another is that Saturn's rings were created when a passing object ripped apart a moon that was orbiting too close to the planet. A third possibility is that the moon was destroyed by a giant storm on Saturn. But regardless of how it happened, we know that Saturn's rings are partly ancient and partly young. This makes Saturn unique in our solar system. We haven't seen this mixed ring structure anywhere else. And you know what? I bet you didn't see this coming. Ancient and young rings. It's almost like Saturn had two different ring makers or something. One started way back when Saturn was a baby, creating those ancient outer rings. And then another ring maker showed up later, creating the young inner rings. Or maybe it was all one ring maker. Maybe it was Saturn itself. Maybe the planet formed the ancient rings when it was young, and then when something came along and messed up its rings, it caused Saturn to enter a more active period of ring making, forming the younger rings. Whatever the explanation, we'll probably never know for sure. But that's the beauty of science. There's always more to discover. Thank you for watching this video. If you liked it, please subscribe. And if you want to watch more videos like this, you can do so here.